My dear students, now before starting on the trickling filter, let me remind my dear students of one point. If you have any doubts, any confusion, you can give a comments in the YouTube. And with the effort uploading in the YouTube, some of the miscreants are trying to mention some ugly words, ugly comments, which I need to sometimes filter it. So please avoid. This YouTube is especially meant for educational purpose without any other objective. It is just for the benefit of the students throughout the country. Even though I have only 28 students of my class, still I can find that more than 113, 114 students have subscribed my video. That means more students are benefiting from this video. So I request any other miscreants who are trying to nullify the video, please avoid such things. Let's think in a better way for the students. Okay, the next one, now just to rewind, in a sewage treatment plant, okay, what we do is the first is always the screens. After all the floating materials are removed, all the grit particles are removed in a grit chamber. This is type 1 sedimentation. After that, the next one is followed by a primary sedimentation tank. The primary sedimentation tank is also something like type 2 without any coagulant, without, I'll say, chemicals. Now the floating materials are removed, the grit particles are removed, the total suspended solids are removed, even though effectivity may be different. Our next target is to remove the organic load. Next one is to remove the organics, that is the nutrients, that is the BOD and a COD. Okay, so for this one already we have done, this is called biological process. In this biological process, as I have taught you in the last semester, here the basic concept is for all these organic foods to be removed, we fed the microbes itself. This is the microbes, and these are the good food of the microbes. These are the BOD. So let the microbes eat the food, they will expand the population. The population will expand. In the meantime, the BOD will decrease, and this population is nothing, it is a sludge, and we can remove it as a sludge. This is the mechanism. Okay, now what happens is this biological process we classify in terms of aerobic, and another one is anaerobic. The microbes can be classified in different ways in terms of reproduction, like sexually or asexually, in terms of other reproduction like spore formation, budding. But being an environmental engineering or civil engineering background, we doesn't have to study much about microbiology, but rather you have to focus on two things. That is the bacteria, they can require aerobic oxygen, bacteria that doesn't require oxygen anaerobic. Example is septic tank. So this example is the reactors like UASB, which is not in your syllabus, only the basic concept. So for the aerobic part, again, how we classify is, one is, I'm just reminding, one is the attached growth, and one is the suspended growth microbes. So in attached growth, already you have come across the word called trickling filter. I think trickling filter in the environmental one already I taught you, but anyway design I will be teaching you again. And for suspended growth, it is the activated sludge process. Activated sludge process. My next topic will be designing the trickling filter and the active distillation process. Okay, so this part, first one is trickling filter. Let me draw the figure. You can read in your own textbook itself. Fine. I'll explain it. You don't have to worry. So this will be hidden. Okay. Now inside this, you'll have a lot of. Now you can read from your textbook. See, the height may be around 1.5 to 2.5 meter. This is a trickling filter. Let me explain you a little bit of the operations. The wastewater is fed from the bottom and it's lifted it up. Okay? When it is lifted it up, this is a like a helicopter blade. It's rotating very, very slowly. And these are all pores. From here, the water droplets will fall down. From here, okay? This is a nozzle. Okay. So here, the thing is, when the wastewater is sprinkled from the top with a rotation, it is going to dissolve DO from atmosphere. This wastewater contains already number one, it has a BOD. So dissolved oxygen is absorbed from the atmosphere when it is rotating and splashing on top of the reactor. Why it is small nozzles? Because smaller is the nozzles, more it will be the surface area of the wastewater. If you have just a bucket of wastewater, the surface area will be quite minimum. But if that bucket of wastewater, if you sprinkle it, all the molecules or the particles will be able to have a surface area and enhance the surface area and enhance the absorption of the dissolved oxygen from the atmosphere. So this sample itself contains BOD and this sample contains dissolved oxygen. So the aerobic bacteria can become directly attack onto this wastewater. Okay. Now, when this wastewater has been fallen onto this trickling filter, what happened is, let me enlarge. This is a media. This can be broken chips, bricks, broken bricks, or stones. Okay. Now what happened is, when this wastewater, this contains a lot of BOD plus dissolved oxygen is there. Over here, some bacteria, they start growing over here on the surface of the media. So when this wastewater falls on top of this one, they will try to eat the food because this is aerobic bacteria. the food itself have oxygen and BOD, so they will eat the food, and in the due course of time, this wastewater will fall down here. So this wastewater is free, not completely free, but free from BOD because the BOD is eaten by the microbes. Okay, so in the due course of the time, this layer will keep on increasing. Now, another example I'll show you. This is the broken chips. So in the due course of the time, the microbes will keep on thickening. Okay, this is called thickening or population of microbes. Okay, they are growing by clinging. They are growing by clinging on the surface of the media. That's why we call it attached growth. Now, what happens is some bacteria are there that is inside. This bacteria, this red part bacteria, the bacteria in the innermost, with the due course of time, this bacteria will not be able to have any food or oxygen because the layer keeps on increasing and increasing. Correct? So finally, this bacteria, what happens is in the innermost, they're deprived of food, and finally they die. Once they die, the power to cling onto the surface, since they die, they cannot cling anymore to the surface and they falls down. Okay, so when this layer falls down, the whole biomass will fall down. Rather, I call it thickening of population microbes, or this is also called biomass. They will completely fall down. So automatically a new layer will be developed again. So this process is called sloughing of filters. Okay, and this is the mechanism of removal of BOD in a COD by using a trickling filter. Is it clear? Okay, the depth is quite constant, 1.5 to 2.5 meter. This concept already I've explained to you in environmental engineering 1. Now, my topic is, let me talk you in the design of what should be the diameter. This diameter is equal to what? This is a design of a trickling filter. Okay? So now let me design the trickling filter. Okay, clear? Let me use a little bit of water. So let me continue it also. It's very, very difficult to control online class. Sometimes you'll hear a noise from outside which is not beyond my control. Sometimes the baby rushed in, even though I'm not the British Prime Minister. Somehow we have taken all these things. Okay, now the whiteboard looks clean. So, first thing is the design. Okay. Now, for the design of the trickling filter, we use a lot of equation called NRC equation, Rankine equation, we used Eckenfelder. Only we'll be using this equation, okay? NRC equation. Okay, but why I'm writing the equations, because sometimes in the 2 marks they ask the match the following. Eckenfelder. This equation is used for what? It is for design of Trickling filter. There is a completely different book written by Eckenfelder itself for the complete design of a Trickling filter. The reason is whatever we are going to use the equation, none of them are the exact equation. All are empirical equation. So Eckenfelder also tried to develop some equation after overcoming the loopholes of the NRC-Rankine equation. But however, this is beyond the syllabus of BTech, especially for MTech or PhD. So right now we'll be using only the NRC equation, okay? And as per the equation, what it says is the efficiency is equal to 100 divided by 1 plus 0.0044 root over, we call it WVF. You'll come to see different languages in the books. Sometimes you'll see this as micro, just a unit. And in other way, this is nothing. This is W V into F. Now, let me make this W also as Q into S naught. This is a simple fundamental. You'll find different notations, but all have the same meaning. Okay, that means the efficiency of a trickling filter is given by this equation. Okay, now the question comes: what is Q? What is S naught? What is V? What is F? As we know, Q is equal to discharge. Oh, still it's a little bit weird. It is a discharge in meter cube per day. Now S naught. S naught is the BOD incoming. The unit is milligram per liter. But remember, when we have this Q into S naught, this is meter cube per day into milligram per liter. Okay, and the unit obtained should be kg per day. My point is this Q into S naught, this one should be in terms of kg per day. So here, how you can convert? There is meter cube. If you want to convert into liters, it can be 1 meter cube is equal to 10,000 liters. 1,000 liters. So this is 1,000 liters day. Milligram is 10 to the minus 6 kg liters. So liter can be cancelled. Kg and day will be there. So this is equal to 10 to the power minus 3 kg per day. Okay. My point is this unit should be in kg per day. You cannot make it into milligram per liter. The reason is you can see this part 0.0044. In some textbook you'll find this as 0.44. Somewhere you'll find as 0.000044. My point is if you want 0044, this conversion, this unit should be kg per day. Okay, number one. This is number one. Number two is volume is meter into hectare. Okay, this is the unit. If you want to convert it, hectare is nothing. Meter into 10 to the power 4 hectare, meter square. Because 1 hectare is equal to 10 to the power 4 meter square. So this is 10 to the power 4 meter cube. So this part should be in terms of meter into hectare. You have to be very aware of this part. The QS naught should be kg per day. Volume should be in terms of meter into hectare. Okay. Now, what is F part? F is equal to, we call it recirculation factor. F is equal to, we put it 1 plus I by R, 1 plus I by R, 1 plus 0.1 I by R whole square. Okay, I think I have not made a mistake. This is R by I. This is also R by I. Now let me explain this part. What it says is sometimes the trickling filter percentage is not very good. So what we do is some of the wastewater are recycled back again to retreat it again. It is just like some students have to appear to exam twice, while some students have to appear only once. Similarly, this R is the recycled part, and I is the incoming part. Okay. Okay, now let's say if I recycle 50% of the wastewater coming, the wastewater is completely treated and it left, but I remove 50% and again I recycle it back. Okay, then that time recycle will be how much time? It is 2 times. Okay, so based on that, this will be the ratio will be 1.5 and you can find a value. Now the next one is over here. One thing what I like to mention is if recycle is equal to 0, that means there is no recycle. This is called standard. If there is no recycle, then R is 0. Therefore, R by I is equal to 0. Therefore, this is 1. So therefore, this term will be 0, it is 1. So this will be 1 plus, therefore, F is equal to 1. This also you have to remember. Okay? Fine. Is that clear? Now, for designing of the trickling filter, let me do a very tough question, one question that is going to compel or compress all the difficulties and will make it all in one question. Okay, you please see this one. I'll write the question. Excuse me. The smell of this ink itself used to be sometimes sneezing, but don't worry, it's not because of COVID. It's not COVID, okay? Now, the question it says a Seaways is saving 3 mld. That means the Q is 3 mld. And the incoming BOD is 250 milligram per liter. BOD removable in primary is equal to 25%. Effluent BOD, that is the permissible is 30 milligram per liter. These are the questions, okay? These are the given data. Now the question is, by what percentage diameter has to be changed if filter is designed for standard but modified to high rate tricky filter with recirculation is equal to 1.5. Now let me explain the question. What it says is there is a sewage incoming, that is Q is equal to 3 mld. Now before going to the drinking filter, in the PST part, here it removes already 25%. Therefore, the next unit that is coming for drinking filter, this is going to be 100 minus 25. This is 75%. Okay. Now, in this drinking filter, he is going to design one as standard. Standard means recirculation factor is equal to 0. Another one is high rate, that is R is equal to 1.5. So when you design this, the diameter of the drinking filter will be a particular value. When you design for high rate, the design will be for a particular value. So if you want to recycle it, definitely the volume will be large, the diameter will be large. The question is, what will be the change in the diameter from this to this? Is the question clear? Now, let me explain you the question once more again. The incoming sewage is having 3 mld, and initially before reaching the tricking filter, in the primary sedimentation part, 25% of the BOD is already removed because some BOD may be in terms of floating or in terms of primary sedimentation part. So automatically by settling, 25% is settled down. Now incoming is 75%. This 75% is to be treated and expected effluent. Here the effluent is 30 milligram per liter because it is going to be thrown into the river. The permissible limit is 30. So this 75% left should be only left with 30 milligram per liter. Something has to be removed. To remove this one, the questionnaire wants to design in two ways. One is standard design, there is no recirculation. Number two, to remove the efficiency, he wants a design in high rate trickling filter. That is, recirculation ratio is 1.5. So since this is going to be high performance, the diameter of this will be higher than this. So how much the diameter will be changed from here to here out of this two design? That is the question. Okay. So now let me continue with the solution. Now, simply what you write is percentage is equal to 100 divided by 1 plus 0.0044 root over QS naught by V into F. So we want to find the performance of the trickling filter. Q we have, S naught we have, F we have to find the volume. Okay. So this volume is the one we have to find. Is it okay? Now, what is Q? What is Q? Q is not 250 milligram per liter. Q is, sorry, what is Q? Q is 3 into 10 to the power 6 into 10 to the minus 3 meter cube per day. That is 3000 meter cube per day. This is Q is number one. Number two, what is S naught? S naught should be in terms of kg per meter cube. Okay. What is S naught? S naught is 75 percentage of 250 milligram per liter. That is 3 by 4 into 250 milligram per liter. Okay. So let me make it very accurate. So it is 187.5 milligram per liter. Therefore, QS naught, we can make it Q also, still we can make it like this, 3 into 10 to the power 6 liters per day into 187.5 milligram per liter. This and this can be cut. This 10 can be in terms of kg. So 3 into 187.5. So this is 562.5 kg per day. This is the value of QS naught. Okay, so one we have. QS naught is 562.5 kg per day. We want to find this one. What is F? F is already, I told you, it is 0 because no R recirculation. Okay, so what is efficiency? Okay, I can remove this part. Efficiency is always in minus out divided by in into 100%. The incoming BOD, what we expect is 187.5. 187.5 has to go in, and coming out should be 30 milligram per liter as per the permissible. Out of 187.5 into 100, this is 187.5 minus 30 is equal to, this is 84%. That means to achieve an incoming of 187.5 milligram per liter and to throw an effluent of only 30 milligram per liter, the plant should have an efficiency of 84%. Right? Therefore, can I say like this? 84 is equal to 100 divided by 1 plus 0.0044 root over 562.5 divided by volume. Therefore, volume is equal to, now it's very easy to find volume, 84 by 100. 0.84 minus 1. No. 84, it should be 184. This should be reciprocal, right? So 100 by 84 is equal to this, minus 1 is this, divided by 0.0044. That root over, I have to remove the root over, so square. The square is, I got a square, or I'll say, I got a square. This by this is equal to, this value I got it. So V is equal to 562 divided by this value, divided by 562.5. I should take the inverse. So volume is equal to 0.3, fine, 0 meter hectare. That means 0.30, actually it is 0.301 into 10 to the power, hectare means 4 meter square into another meter. So this is 3001 meter cube. This is the volume. Is that okay? Now, therefore, depth is equal to, you can assume as 1.5 meter. Therefore, area is equal to volume by depth. That is 3001 divided by 1.5. 3001 divided by 1.5. That is 2000 meter square. And area is nothing, pi by 4 d square. Therefore, d is equal to 2000 into 4 divided by pi root over to 4 divided by 22. That is 50.5 meters. Now, I can say that the diameter for standard is equal to 50.5 meter. Number one. Now let me find for the another one, that is a hybrid tricking filter. Okay, for the hybrid tricking filter, I think this is clear. For the hybrid tricking filter, we have to change the value of the recirculation factor. Okay, so now if it efficiency is equal to 100 by 1 plus 0.0044 root over q s naught v into f. So f is equal to, I told you, 1 plus r by I plus 1 plus 0.1 r by I whole square. Here they said r by I is equal to 1.5. Recirculation factor is 1.5. Therefore f is equal to 1 plus 1.5 divided by 1 plus 0.1 into 1.5 whole square. That is 2.5.1 into 1.5 is equal to plus 1 is equal to square, and then divided by 2.5 is equal to, I have an inverse. So this is 1.89 is the value of f. Okay, so the next part is, this efficiency is what? 84. 84 is equal to 100 divided by 1 plus 0.0044 root over QS naught. I think that is 565 divided by volume into F is 1.89. Therefore, V is equal to, okay, V is equal to, so what I got this value is 1 by V into 1.89. V is equal to, V is equal to at 1595 point. This is meter hectare. Let me check again. 100 divided by 84 is equal to, okay, minus 1 is equal to, divided by 0.0044 is equal to, then I have to take square. I have taken it, divided by 565 is equal to, okay, into 1.89 is equal to, this inverse I have to take. Okay, fine. So this is equal to 0.1595 into 10 to the power 4 meter square into meter is equal to 1595 meter cube. Assume diameter is equal to, depth is equal to, same, 1.5. Therefore, diameter is equal to 1.95 is equal to 1063 meters square. Therefore, dia is equal to 1063 into 4 divided by pi whole root over. Correct? 1063 into 4, 36.8. This is 36.8 meter, number 2. So our first diameter 1 was, this is for highway, and another diameter for standard, I remember it was 50.5 meter, correct? Now the question is, this is the diameter we wanted. If you want it for a hybrid trickling filter, this is the, this is the hybrid trickling filter, this is the new one. So what is the change? What is the change? The value is correct? Therefore, change is equal to, that is 50.5 minus 36.8 divided by 36.8 into 100. That is 22%. You have to decrease. Okay? The value is not 50 minus 36.7. 50.5 minus 36.8 is equal to 36. Oh, 50.5 minus 6.8 is equal to, oh, this is 37. Okay. So now the question means, in a standard one, since there is no recirculation, the required diameter is very, very important. The reason is, since there will be, in the previous assumption what I made, some error is there. If you are going to treat 84% of the wastewater completely, the 84% in a single go, diameter has to be large. But if you want to recycle it again, even though the amount of the wastewater is high, the reactor is going to work twice for the same sample. So diameter will be decreased, the area will be decreased. Okay. So the decrease, or rather you can say increase. If you want to say from the standard to the another one, then it is decrease. If you want to say from the hybrid trickling filter to the normal, then you have to increase. Whatever it is 37%. This question comprises many, many questions. Number one, here is two numerical itself. One is for the diameter when r is equal to 0. One is for the diameter when r is equal to 1.5. Remaining all are just a combination of the basic concept. Okay. So this is about the design of the trickling filter by using an RC equation. Again, Felder, we won't be teaching you. In next class, I'll be coming with the activated sludge process along with the concept of how the hybrid trickling filter should be there in every part of the sewage treatment plant. That will be taught along with the activated stress process. So for today, thank you, my dear students. And please, I remind here again, please don't write any rude or any comments that affect the other students. This video is specially meant only for educational purpose and for no other reasons. Thank you.